Please read the questions, try to solve it, and come back. So, the problem is asking, given this picture A, B, and C, and D, and E, in which case is the object slowing down and turning to the right? Wow. Let me think. Turning to the right. Slowing down. There are two. In which case is the object slowing down and turning to the right? Two things at the same time. Okay. Maybe. Okay. So this is the idea. When I have an initial velocity v sub I, and I have the change in the velocity will produce a new velocity v final. It's like your money, but your money doesn't have any direction. Your initial money with the change will be your final money. Okay. So we know this equation that the acceleration is the change in the velocity per unit of time, and we know that the change in the velocity is a by delta t. So this is the change in the velocity. So in the first picture, we have v sub I in this direction. We have a by delta t will be in this direction. So v final will be this one. So this v is changing, in which case the other is slowing. This v is slowing down, but it's not turning to the right. So the option A is not the one. So let's go to B, to this picture V. This is V final. Okay. And this is the change in V. So V final is the change in V. So let me erase here. So this is V initial. This is V initial. This is A is going like this, A is going like this, here like this. So A by delta t, that is the change in V, is going like this. And V initial plus the change in delta V plus this vector is the final velocity V final. So V final is here. So he is slowing down and turning to the right. Well, he's turning to his right. No, the vector final velocity is rotating to the right. And now it's slowing down. It will have a slowing down means that the final velocity will be smaller in magnitude than the initial velocity. Well, I'm not sure, because if Vi is like this, and the change in the velocity A by delta t is like this, V final will be like this. V final, V initial, and the change in V equal A by delta t. So the object will be rotating to his right. So imagine a car. So the car is rotating to his right, but his velocity is increasing if you consider this big change in time. So maybe B, this one will work. Let's go to the other option, C. C option is when the velocity initial is going in this direction, V initial is going in this direction, and A by delta t is going in this direction. I have to, if I want to sum V sub I plus the change, I have to put the change in the head of V sub I. So V initial plus the change is V final. So this is rotating to the left. So this is not one. This is not this one. So C is not. Let's go to see D. D, well, where is D? D should be here. No, D is not here. Let's go to do it. V is, this is V initial. V initial. I'm doing V initial. This is the vector V initial. Now it comes A by delta T. A by delta T. A goes like this, in this direction. And A by delta T is the change in the velocity. So it will be something like this. This will be the change in the velocity. So the V final will be this vector. Is this vector rotating to its right? Yes. Is increasing the magnitude of the velocity? Yes. This is the D. This is good. D is good. Let's go E. Let's go to see E. E. The V initial is like this. The acceleration is like this. But the acceleration, A by delta T, is the change in the velocity. So the change in the velocity is what I have to add to V sub I. So let's say that A by delta T is this vector. So B final, it will be like this, and now it will work also. Is rotating to his right, so this is V final, and is instantaneously speaking is not increasing his magnitude. It's difficult to explain why instantaneously an acceleration that is perpendicular to the initial velocity is not changing. But if you keep the acceleration in this direction, this final velocity will change in magnitude and will change in the direction to the right. So I should say that E is also possible. So what we said, D and E is possible. A, let me see, A by delta T, yes, A by delta T. I think that D and E are possible, both of them. If you maintain it's rotating to the right, yes, rotating to the right. I think this is correct, but in any case, what I have explained you is correct. Delta T, oh, sorry, go to the next question. So read carefully, try to solve it. It says, for a general projectile motion with no air resistance, the horizontal component of a projectile velocity, we have said that the initial velocity, the x component of the initial velocity maintains constant. So the horizontal component of the projectile velocity, it maintains constant. So continuously increase, no. Continuously decrease, no. Continuously decrease, no. Remain non-zero constant, no. Remain a non-zero constant. Well, first decrease and then increase, no. Continuous increase, no. Continuous decrease, no. The remain a non-zero constant. Remain a non-zero constant. So maybe it means this one. Remain a non-zero constant. Remain constant and not zero. Maybe this one. Remain constant. Maybe it's D. Maybe it's D what it means. Yes, D. Okay, let's go to the other question. A ball is thrown horizontal from the top of a tower at the same instant. So this is a tower. So it's thrown horizontally with certain velocity. So it will do like this. At the same instant that a stone is dropped vertically. So there is another stone here that is dropped. So there is no initial velocity going downwards. Well, also this one doesn't have any initial velocity going downwards. So the two of them, they will be launched in the same initial condition for the y. The y0 will be the same, and the v0y will be the same, 0, the initial velocity. So which object is traveling faster when it hits the level ground below if neither of them experiences the stone? Which object is traveling faster when it hits? Well, when it hits the floor, this is the floor, let's say this is the floor, the object will be an object with constant acceleration, so the velocity increase. So the object that is being launched will arrive with certain velocity. This one will arrive with certain magnitude of the velocity that is tangent to the trajectory, so they will not arrive. So what the problem is asking is this initial velocity, is this final velocity when he hits bigger than this, the magnitude of the velocity, because the directions are different. Is this magnitude bigger than this magnitude? And the answer is yes. This magnitude is bigger. This magnitude is bigger than the final magnitude when he hits. Why? Let's go to say why. Because for the stone that is being launched vertically downwards with velocity initial 0, v final is v0y minus g by t. So v final is minus 10g by t, because v0y is because v0y is 0. See, this is for the one that is thrown vertically. For the one that is thrown with horizontal velocity, the velocity will change, but v0x will not change. v0x will be v0x, and vy will be v0y plus a by t. So v0x will not change, and the equation for vy will be v0y 0, because it's launched, minus g by t. So the vy will be minus gt for the object, and the other velocity v0x is maintained constant, v0x. So the velocity, the magnitude of the velocity when it arrives to the to the floor, it will be a square root of v0x squared plus g t squared. And this magnitude, because it delayed the same time to touch the floor, this magnitude, that is this one, is bigger than this magnitude. Okay, maybe there are an easy way to see it. Okay, projectile motion. A pilot drop a package from a plane, so this is the plane, and he drop a package. So the plane continues its motion. This is the plane. And when he dropped the package, when the package hits the ground, the horizontal location, this is the ground. When the package hit the ground, the location of the plane. So when the package is released from the plane, the package has the same initial velocity as the plane, the same one. So he will move in the presence of a gravitational field, in a constant acceleration, but his velocity will maintain constant. So the trajectory will be a parabola, but the x components of the velocity will never change, and the x component of the velocity is the velocity of the plane. So in this time, when he arrived to the floor, the plane will be just here. Just here. Okay, it's a good question. So be in front of the package, depend of the speed, be behind the package, be directly over the package. This is the answer. Okay. You write the equation and you can see clearly the equation. The equation of the plane, x of the plane, is v0x by t. At the time t, you choose this O is here, X, and the equation of the package, or plane, package, stone, let's go to say that is a stone. The equation of the stone is v0x by t, because the velocity never change. So they move in the x direction in the same way. So when the plane is here, the package is here. When the plane is here, the package is here. And when it arrives to the floor, the plane is here. That's all. Next question. Well, read the question and think about. Player. Okay, it's say a player hits the floor. So this is the ball. He hit the ball, and the ball will do like this. Okay, this is the trajectory of the ball, and it's say at his highest point, the velocity he launched with this velocity v. So as we have said, this component of the velocity v0x will be maintained. And at this point, the Vy doesn't exist. There is no y components of the velocity going up or going down. So it's at the highest point, the ball acceleration is 0. No, the ball acceleration is always 9.8. Both the velocity and the acceleration of the soccer ball are 0. No. The acceleration is not 0, and the velocity, okay, neither the ball velocity nor the acceleration are 0. Neither the ball velocity nor its acceleration 0, yes, not the velocity, yes. The ball acceleration points upward, while the ball acceleration is always downwards. The ball velocity point downward. No, the ball velocity points in the horizontal direction. So the only one that I consider could be true is the C. We have finished. Good luck.